Hello all, and welcome to the Resonance Academy Faculty Q&A for October. I'm here with Dr. Ines Urdaneta. Hi, Ines. Thank you for joining us.
Hi everyone. So happy to see you here. Okay, so we're very excited for this new Q&A for this month. Maybe Marshall will pop up at some point. We still don't know, but in any case, well, here we are. Please remember to put your questions in the little spot for it downside. You'll see the Q&A there. So we have already the questions popping up. But before we start, maybe we can have like a little introduction to what's going on in RSF. William, please let us dive into our activities.
Just 1 second, because I need to enable the chat. Okay. Every time now I've got to enable the chat, and I've got to remember each time how to do it. Okay, so our chat is active. So if you want to say hi and where you're joining from, we can see you now.
There you go.
Yeah, so we've got some exciting events occurring coming up here in November with the Resonance Academy. There's a couple new courses that are coming out. So there's one from Sans Meredith Keeter. She's going to have additional content for her fractal geometry course that is going to be, I believe, 4 live sessions, virtual sessions. So there's going to be additional material for her course, which just has a lot of really applicable information in regards to unified physics. So taking that kind of understanding of the connected universe and applying it in your own personal life, and applying it with various modalities, various techniques to kind of activate your body. So that's going to be a really exciting course that's going to be available in just a few weeks here. Then also there is a unified science course that's going to be made available for kids. This is going to be an 8-week course with live virtual sessions. It's going to be taught with Nassim, Marshall Lefferts, Resonance Academy staff like me and Ines will probably be giving some lectures and sharing some information. It's created especially for school-age youths, so that's from 10 to 18 years old. But you know, if you're not exactly in that age range, I think it's still a great learning opportunity because you know, the information is just going to be presented in a very clear and understandable way, so that you know, even school age people can understand it. So that's launching November 3rd. I believe registration's open and available for that. And they've got quite a curriculum lined up for it. So, you know, this is a great opportunity for children who are homeschoolers, parents with children that they're homeschooling, and also children in the more conventional or traditional school setting. This is a great way to round out their science education. I wish I had something like this available when I was a kid, just because it would have saved me a lot of time, because I kind of had to find Nassim, unlearn some of the incorrect stuff I learned, and then relearn it the right way. You know, so it's I think a great opportunity that's being provided. So it's going to be, I think, an exciting course that's available on the Resonance Academy.
Yeah, we are really excited about it. So preparing our ideas to give the children are like the most important concepts in a very, very pedagogical way. So I'm sure that will be mind expanding for everyone. And it's interesting, as William said, for the adults as well, you know, because if you know how to, if you can understand, if you can tell a child and he can understand it, then you know you have understood.
Yeah, yeah.
That's something that Nassim says also all the time. Like, if you're able to explain it to a child and he understands it, then we are ready to go. So it's also a challenge for us. We have to really make it understandable. And so yeah, and then so there are many news also that have been popping out. Well, of course, we have the physics, the novel. I don't know if that was already discussed in our last session. I'm not sure. I think not, because it's recent. No, this is the first Q&A we have after yeah, okay. So we're celebrating the Nobel Prize in physics, of course, given to Entanglement. So how about that? It was about time for it to receive the merits it deserved, you know? Entanglement is like the most important aspect, I would say, of our theory. And although it is predicted by quantum theory, it is not explained by quantum theory. So this is something important to understand. Quantum mechanics predicts entanglement, but it doesn't explain where it comes from. So it is not a real feature of quantum mechanics. And although they adjudicate it to quantum mechanics, it's not coming from quantum mechanics. And the unified field theory of Nassim Haramein, it's the one giving the deep explications, the deep understanding of where really this phenomena is coming from. And I'm really surprised now to see that now everyone's talking about entanglement, which is something that until before the Nobel Prize, it was something very like, you know, we just mention it every once in a while, and now it's everywhere. And they're even taking like popping some news about ancient, not so old news about some experiments done like last year, and I was surprised for that experiment. I thought it was from this year, and it's from last year, where two mini drums, not microscopic drums, two very small drums, but macroscopic drums were being, let's say, I don't know how to say that, stimulated, so that they would vibrate at different frequencies, but they could prove that their movements were entangled. So imagine that this is like a dynamical entanglement of the movement of the two drums, which is something huge, because this is proved at microscopic scale. And this had not given the proper credit it deserved, you know, this kind of findings. They're just like not well disseminated. So people don't know exactly what the implications of this has. And suddenly there's the Nobel Prize, and now they're popping this news everywhere, like, oh, this is very important for nature of reality. Oh, here, and come on, guys. This has been, of course, the situation since 50 years ago now. So yeah, it's funny to see how these developments unravel in mainstream physics. And so that's and well, many things have been happening. Vortex structure has been finally admitted in. They have found that black holes admit vortex structure, which is the main prediction of Nassim Haramein's model. Just precisely that there should be vortexes, because the black hole is a vortex on itself. So yes, the vortex structure has been finally understood in terms of Bose-Einstein's condensates. Of course, this is some parallelism found between Bose-Einstein condensates and black holes, which is like, let's say that Bose-Einstein condensates are the lab from which we can unravel many of the mysteries of black hole physics. So this is something very interesting as well. And well, many news have been popping out that are like crazy. So I mean, so revolutionary, and they're really heading in the direction of supporting the unified field model that we disseminate here. So well, yeah, very nice.
It's almost been difficult to report on all of the new findings that are coming out, because there's been so many kind of back to back. And, we like to take that information, collate it, and present it. So I actually, on the Resident Science Foundation website, we have a science section with articles, and we report on many of these findings. So you can find more information about that in the article section. The Nobel Prize that's been awarded for the work on entanglement, which is, just very important, very significant to understand what exactly was done there to understand this fundamental property of the universe, this property of entanglement, and some of the implications it has, particularly for unified physics. And then there's a number, I think, of really good articles that are available. And one of the things that we're going to start doing, we're going to try is for our breakout group sessions, we're going to select one of the articles from the science section, provide a link to it, where you would access the link to go to the breakout room session, and we can open up the breakout group session with a focus of discussion on one of the articles. So, for instance, we just recently did the galactic engines report, which is actually a great primer to the paper that's going to be coming out from Nassim and Dr. Olriol very soon. Understanding the basics of the information that's presented in that article is going to be, I think, a great start to the paper that's coming out very soon here. I'm looking forward to this kind of new format for the breakout group session, where we can explore some of these most recent findings in science that are all supporting and validating much of the work that we've been doing for a long time now.
That's a great idea, William. I like it. It's a beautiful idea. And now I was reading the comments along, and yeah, Andrew Javlov is saying that even in very mainstream New York Times, yeah, this is what I'm saying. He just shared a link from New York Times, black holes cosmology hologram. We have shared that in our chat, and this is like everything. It's popping everywhere. It's like very interesting, very important times for us. And so I was going to say also that I forgot. I was going to say something I forgot. Okay, so oh yeah, I was reading your last article, William, and it's lovely about the creation of particles from the. Maybe you would like to talk a little bit about it.
Oh yeah, because it's just it's such a interesting experiment that was done, and the findings couldn't be more exciting, because there was an experiment that was reported this last spring, actually, in the journal Science. So this is work that was very rigorously evaluated, via the peer review process, and it involved an international team of researchers from Japan, the US, the UK. It was led by the University of Manchester. And what they were able to do was show empirically particles being created from the quantum vacuum. This is a significant finding, because even today, decades and decades after the substantive nature of the quantum vacuum was described in conventional physics theory, it's still the case that many scientists, physicists even, consider space as a true vacuum, that is, as empty. And even some of the words that are used to describe the energetic nature of quantum field theory kind of denote this idea that it's imagination. So like in quantum field theory, the vacuum or empty space, that's space that should be devoid of any particles, forces, fields like the electromagnetic field, the gravitational field. Already, this is a very hypothetical construct because, I mean, how do you get rid of the gravitational potential energy? I mean, it's like the gravitational potential energy from all the stars in the galaxy, all the galaxies in our local cluster, all the local clusters in the supercluster. I mean, even the gravitational energy in a cubic centimeter of space is tremendous. It's actually, yeah, but so we're already kind of in a hypothetical type structure where you have true empty space. What quantum field theory says that when you do the calculations and the analysis of that with the quantum fields, they're always undergoing energetic fluctuations. So in the parlance of quantum field theory, this is described as virtual particle fluctuations. But you can see there that term of virtual, the idea that these are kind of like imaginary or non-real, non-physical things that are occurring, that it's like, yeah, you need to include it in the mathematics to get the right output, but it's not really there. That's kind of the perspective.
Exactly, and that they pop in and out of existence at such a speed that they don't violate conservation laws. So that's a very part of that.
But once we start to move towards okay, so how do we explain things like a particle mass? How do we explain things like the source of forces and fields like the gravitational field, the electromagnetic field? That is a unified physics. One of the foundational understandings to actually get a theory that is going to have the ability to explain these fundamental properties of the universe, you need this substantive medium. That space is never a true vacuum, that it always has a constant energy density. And so one of the disconnects that occurs is, so once you start getting into like, the model that's presented by Nassim Haramein, where space is comprised of these Planck particles, the Planck plasma, and you can use that to describe the source of particle mass, the source of gravitational force, electromagnetic force, and what they're showing more recently, the source of all the constants and forces in nature. You get this disconnect where physicists are saying, well, I don't think that the vacuum, that these virtual particles are real, that this energy is real. So even to this day, it's a major challenge in bringing this information so that many can understand it. Because it needs to be understood, the nature, the substantive nature of the quantum vacuum. So what these experimentalists did is they were able to utilize a prediction, a 70-year-old prediction by Julian Schwinger. He was one of the first physicists working within quantum electrodynamics to predict particle creation from that vacuum energy. And what he had done was analyze what happens if you generate a very strong electrical field. So in an electrical field, charged particles are going to be influenced by that field. So if you have a positively charged particle and a negatively charged particle, if they move through that electric field, they're going to have divergent trajectories because they're influenced. The positively charged particle wants to go towards the negative end of the electric field. The negatively charged particle wants to go towards the positive charged end. Well, if you get a sufficiently strong electrical field established, even those so-called virtual particle pairs. So like your electron positron particle pairs that are constantly being created within the vacuum energy density, those particle pairs won't stay bound together where their net effect is canceled out. In the strong electrical field, they'll actually diverge from each other, even within the vacuum structure, and it'll appear like they're popping out of the vacuum, like the vacuum is generating these particles. They're always there, but because they're in a sense in equilibrium, at macroscopic scales, the net effect just kind of cancels out, and so it looks like there's no mass energy there, there's no charge there, but if you can get this gradient created in the structure of space via, in the case of the Schwinger effect, via an electrical field, you can actually get these particles to separate from each other. And now, they're not totally canceling each other out. They're not totally balanced. So you can actually see that they're there, see that these so-called virtual particles aren't so virtual. The thing is that the Schwinger limit is an extremely strong electrical field, so strong that there's no current way to generate that on Earth. It's like a tremendously strong electrical field. So, it's been thought that the only way that this prediction of quantum field theory, quantum electrodynamics, the only way it would ever be observed or probed and possibly verified is by studying astronomical objects that do produce these kind of gradients in the structure of space and the structure of the vacuum. And these are objects like neutron stars and black holes. And indeed, with neutron stars, they had, I believe in 2018, observed this gradient structure being created in space, in the vacuum structure around neutron stars. And they were able to see that the pulsed light emitted from neutron stars actually undergoes birefringence. So what that means is that as the light's emitted from the neutron star, when it's going through the vacuum, through space has undergone what's called spatial symmetry breaking, so that it's in a crystalline phase, and the light passing through it, depending on its polarization, will have different speeds and different trajectories. So it actually splits light beams apart. And so this has been observed and documented around neutron stars. So again, another direct observation, verification of the substantive nature of space, this crystalline phase of space. Similarly, the idea is that the only way you're going to get these kind of field strengths that generate a strong enough gradient to start to extract energy from the vacuum is via like neutron stars and black holes. So like Unruh-Hawking radiation is another example. It's kind of like an analog of the Schwinger effect, where instead of generating an extremely strong electrical field to separate electron-positron pairs, charged particle pairs of the quantum vacuum energy fluctuation, you use an extremely strong gravitational field. of the black hole, and that separates particle pairs. And then you get like Hawking radiation, so-called Hawking radiation. But this research team more recently was able to utilize some of the more phenomenal properties of graphene it was kind of a neat, a clever trick they were able to utilize with the graphene to induce the kind of field strengths, the kind of electric field strengths that would surpass the Schwinger limit, so that they could actually observe and document these particles being created from the vacuum by establishing this gradient in the structure, so that it doesn't all just net zero. You need this gradient. One of the things that Nassim Haramein describes, and how he describes how the substantive medium is the source of mass, it's the source of forces like the gravitational force, fields like the electromagnetic field, is via producing a gradient in that energetic structure of space. And one of the ways that that happens is via a spin. Spin will create a gradient that allows for that energy to not just totally net zero. So it's a really, I think it's going to be a really important experiment that was done, because you can point to what was done and show that the energy of the vacuum is very real, and there are methods, modalities that can be used to extract that energy from the vacuum.
It's amazing, because graphene is such a mysterious material that you just reminded me. It was with graphene that they proved that thermal motion could be used as a source of usable energy. Exactly. And
oh yeah,
you remember that word?
Yeah.
But that thermal motion is just it's just energy that you lose through like heat. You just lose it, you cannot harvest it. And the thermal motion, it's like that same motion that would come from these same fluctuations of the field, which are supposed to be canceling out and you cannot use them. But they proved in graphene that thermal motion could indeed be created, could be harvested to use energy. And it was a mini over unity device, because you could extract more energy than what you were injecting to. But they wouldn't, say it explicitly like that. But that was some of the findings they had like 2 years ago with graphene. So it was amazing to see this. Graphene is just an incredible material. That was so great. I was curious about this electric field magnitude. So yeah, it was through graphene, exactly. That's amazing. Okay, so maybe okay, let's maybe go to some of the questions here. I see we forgot maybe to mention that you have to, well, you could vote if you want to see which one are the most interesting for people. Yes, I saw that there's a vote already. Okay, so we have as a first question, let's say, according to Dr. Greer and others, energy generating over unity devices and gravity control devices have been made for years, and they and their creators have been suppressed. How might or might not this situation change with the publication of the upcoming paper? That's a great question, Andrew. Do we know how should we put him into the?
Oh yeah.
Okay. Yeah. Yes, yeah, I had in fact, he's doing an event recently in I think the 25th of this month. He's doing an event, Stephen Greer. I'm gonna try to join. I would like to see these other technologies he's referring to. Yeah. So we only wait for his camera to load. Okay. Hi, Andrew.
Hello, where am I?
We can probably hear you, but we don't see you.
Wonder what I have to do. Well, I'll try to figure that out. You talk.
Oh, okay. Thank you. Okay, so I guess you're aware of Greer's event coming up soon, right? In the
Yes.
25th. Yeah, okay, yeah, that's an interesting thing to see. Well, maybe you can turn it, there's a little icon you should have somewhere. And they should say turn on video. Maybe you can find it in the icon of stop video, or there's a little icon that represents the video. So maybe if you click on there, if you find it, you can have your video activated. You have to have your camera opened. You it's just many times I forget, so that's why I'm reminding that. So okay, so in my opinion, Greer's let's say disclosure of this technology, it's just going on the direction of like giving more support to what the theory that Nassim's going to publish very soon, because you know, one thing I have seen, I have met people that have very interesting technologies here in Mexico. The problem is that their technology is based on let's say a science that is very difficult to explain. How to make people understand the science, the physics that's used behind this kind of developments, no? Because even the experimentalists are not so clear on how they did it. It's very intuitive. So they just have the intuition that they should mix the things and then go through this procedure and maybe use this kind of geometry, but there's not a formal, let's say, explanation on why this is working. And this also happens in mainstream physics, you know, because for instance, we think that, and this is how it is explained in physics, that the current is electrons flowing from one side to the other, you know, and then we don't really understand how current actually flows. I mean, there's no flow of electrons, it's just a transfer of energy through the electromagnetic field. So this is what I'm saying, that if you don't know if you don't know deeply well the mechanics behind the phenomena that you're exploring, then you're probably not taking the most advantage of the system. You're probably not, for instance, like nuclear energy. One of the things that we've get questioned a lot is, oh, but if nuclear energy was so dangerous, imagine if you tap deeper into the field. Imagine how that would be, having the Planck energy being used. And I'm like, well, if you really understand what is that energy, then you can probably use it much better. You'll probably know how to utilize it in a much beneficial way. But you really need to understand the mechanics and the concepts behind. It's not some kind of like, so that's something that I feel happened with nuclear energy. We just didn't understand how much we still at that point in mainstream, let's say, current physics is not able to really understand what's happening at the nuclear level. So fortunately, if you have a theory which is providing you of all the elements necessary to understand the origin of forces, of fields, of particles, the relationship between them, the complete feed-forward mechanism, because what Nassim's model is really saying is that there's a flow of information across scales, and this feed-forward mechanism has aspects that we call particles, forces, fields, but they're all aspects of the same mechanism of the feed-forward mechanism of the field, and entanglement as well. So entanglement is part of that mechanism of the feed-forward from the field. So if you really understand deeper enough this connection between all aspects of theory, then you probably are having a much more robust comprehension of and visualization of what has to be done in order to do it safely and in order to do it in the best way possible. And of course, you can have, but most importantly, you can transmit this information, this knowledge to more people. Because if you have your own technology, but you don't know how to explain it that well, if you have your, let's say, your own science, just to say it's sort of, and you don't know how to communicate that because you're understanding it from your own perspective in a very intuitive way, then it is very difficult to have other people, you know, engaging in this kind of of language, because it is a language that you're creating. And if you don't have that understanding, it will be very difficult. Only those of you who understand that kind of intuition will be able to have that kind of knowledge and that kind of technology. So the idea is to provide a whole complete mechanism theory that can make the most of people go to the next level, you know, just like the massive amount of people, like universities and all this mainstream huge Titanic move to the next level, you know. So that's one of the things that I'm confident Nassim's theory will provide. It's just we need that substrate, we need that fundamental understanding of space-time, so that we can really move to the next level as a collective. Because of course there's this, and probably that's the reason why these suppressions have happened, because they have not included, you know, they have not included this understanding which can be disseminated among everyone, you know. It's just, it keeps being like too restricted to maybe occult is to say the name that they find is most close to that. And so because not that much people can be implicated, then it's easier, you know, to like make like this is not happening or suppress this kind of knowledge or technology. But if you have, and mainstream is already there, because entanglement is just keep saying that. I mean, if you can prove entanglement in microscopic materials at ambient temperature, then what you're saying, what are you really saying about nature of reality? So I'm sure and confident that this is all going in the same direction, and the technologies that Dr. Greer is going to disclose are going to be very aligned to what Nassim's technology is going to put forward once this paper comes out. So I would say that it's just on the beneficial side. I don't think that it would be any, you know, like a reverse, a reaction or something of the sort.
Great.
Which is,
So,
yeah.
so what I hear you saying is the big difference is now we have how it works.
Yes.
Okay, got it. Thank you.
We have it in a very detailed way, in
Yes.
such a detailed way that it will be very convincing to everyone, you know.
Yeah.
You know, because I have seen many types of technology here in Mexico, and incredible technologies with water that they're doing here. But you could also see that I'm not grasping that when this person is explaining their way of understanding what they're doing, it's very difficult, you know, to engage with that, because it's their own cosmovision of it, you know.
Right.
It's their own cosmovision, yeah, of the problem of this understanding. And so it has to be when on the other side we have a whole infrastructure which is based on the concepts and language that science has already provided, which is what Nassim has developed further, you know. So that gives him like this additional point of
Credibility.
of credibility, of course, of credibility. Yeah, that's it, of credibility, because it will be much more easier for people to understand in mainstream physics. And we saw that happening with the physicist that Nassim had invited in a meeting with us, where she's from the University of Santa Cruz, and when she saw that this is one of the persons that got the download of all the work that Nassim and Olivier are doing, and when she saw this complete model, she was like, wow, you know. And that was beautiful to see, because then you can see that really there's something that has that will arrive where it has to arrive, which is in a deeper understanding for all of science and physics, basically, you know. And that of course permeates all other sciences, chemistry, biology, medicine. All of that will be united with this. So it's really important. And thanks for bringing that up, Dr.
Okay,
Greer.
wonderful. Thank you.
Yeah, thank you. Oh, you had a second question. Maybe we can address it
Okay.
now. Yeah, just so yeah, because I think it's oh yeah, okay. I remember this one. You're confused about the size. Okay, yeah, I know it's confusing. Okay, so you're confused about the relative Planck size, PSU size, Planck size, Planck hole size, and the flower of life. I have heard Nassim say that the Planck scale black hole has 64 PSU inside and 64 outside, but the radius of this fundamental building block of the universe is just 2 times the Planck length. Is this correct? If yes, why are there little circles on the flower of life and lots smaller than 1/2 the flower of life diameter? And how all those PSU get packed in there? That's a very good question. Okay, yeah, it is twice the length. So it is. So what's happening is that at this radio, the system is behaving much more coherently, and so the spheres are much more packed, much more. They're almost like behaving like a single PSU. Let's say they're they're very much packed because they're a Bose-Einstein condensate. So the wave function of all of them together is basically behaving as the same wave function, as the same unit, as the same entity. And that's precisely the size at which the mass starts to unravel, meaning by that's the kernel for mass. That's the limit. 64 is the perfect balance or equilibrium state in which all that's contained in the volume can express through the surface. So that's a perfect balance, perfect flow of information in and out. There's no inertia, there's no loss, there's no screening of information. But that's the limit of it. And after that point, it starts, the screening starts. Okay. So that's why the mass starts there. What a reference of mass starts there,
Okay.
At that level. And of course, the coherence will start creating this boundary condition where you will have a combination of Bose-Einstein and Fermi-Dirac. And then below that, or further away from that, you'll have just Fermi-Dirac, which is the particles already completely differentiated and distinguishable from each other. So that would be the reason why it could be confusing, but that's why, because it's at that point, it's just like a Bose-Einstein condensate. So they're very, very packed.
Okay, I'm going to have to listen to that a couple of times more on the recording. Thank you very much.
You're welcome. You're welcome, Andrew. Thank you.
Okay.
Okay, so I think the next question after that is from Kat Lewis. And this is a biology question, so this is definitely within my purview. My academic background is primarily in cellular and molecular biology, molecular genetics. So I enjoy the biology questions. Kat Lewis asks, I'm curious about why mitochondria seem to only come from the mother. And I'll see if I can pull you up, Kat. If you would like, you can enable your video, but feel free to just chat if you want.
Hi, I'm on. I can't actually see where my video, for some reason it's not up. I just see the mute button.
I wonder if we're having, there might be an issue with having a video for the participants, because it says that you're a call-in listener, like you called in on your phone.
No, I'm actually on my laptop.
Yeah, so there might be an issue going on. I don't.
Okay, that's fine. I can just do it this way. Yeah, I was just curious about, this concept that the mitochondria just comes from the mother.
Yeah. So, well, that circumstance, that peculiarity is actually really interesting for genetic studies, genomic studies, because when you look at the mitochondrial DNA, of any person or any animal, you're looking at their maternal lineage only. So that has some very interesting opportunities for understanding the lineage of any one person or organism. The reason why mitochondria only come from the mother is because the egg cell is the cell that contains the mitochondria. So from the father, you have the sperm cells being contributed. Now, the sperm cells, they have mitochondria. Actually, they have densely packed mitochondria that help to propel the sperm. But all of that mitochondria is concentrated outside and away from the genetic material. So the sperm has the haploid chromosomal content from the father. That's half of the entire chromosome set. But in a compartment separate from that, there's all these densely packed mitochondria that are propelling the sperm, energizing the little flagellum that propels it. And actually, when the sperm binds to the egg, that portion of the gamete actually falls off, so that the only material that enters the egg cell is that haploid genome, the chromosomal material. Now, there are rare circumstances, though, where that separation is incomplete, or there's even mislocated mitochondria on the sperm, so that actually in some circumstances, some rare cases, mitochondrial DNA can make it into the embryo from the father. But even in those cases, you're talking about a numbers game, so to speak, where the mother cell has thousands of mitochondria, and maybe 10 or 20 mitochondria from the father make it in. But it's really just that all the mitochondria that is going to grow and be shared into each daughter cell from that initial mother cell during embryogenesis all come from the egg, all come from the mother.
Yeah, and I guess I was just curious, why would that be? Like, why would the universe design it that way?
Yeah,
And if you guys had any insight into that.
it could have to do with competition within the cell. So the fact that all of the mitochondria are coming from a single source, so they're all sister organelles, that is very conducive to cooperation. And one of the things when you look at the activity of mitochondria in the cell, because you can view them in real time using fluorescent microscopy, for instance, where you can take live cells, you highlight the mitochondria with proteins that emit visible wavelength light so that you can see them in the cell, in living cells in real time. When you do that, one of the things that you see is that mitochondria are extremely dynamic, especially in cells that are, undergoing functions in the body that are like, for instance, high information processing activity. So this is like the neurons in the body. If you look at the mitochondria in these cells, they're constantly interacting with each other. You can see them coming together. They'll actually form what are called tunneling nanotubes, where they'll connect, link up, and share signals, share material, even possibly whole plasmids, their genomic material between each other. And this has been strongly correlated with behavioral outcomes of the cell itself. So to put it perhaps simplistically, what you see is the mitochondria interacting socially, talking to each other, coordinating behavior, and then sending out signals for what the cell is supposed to do, directing the behavior of the cell. So there's a lab at MIT, I believe it's at MIT, maybe Cornell, but it's called the Mitochondrial Sociology Lab, Neurobehavioral Sociology Lab. Because they look at how social interactions of mitochondria within neuronal cells predicates behavioral outcomes of the neurons. And it can even determine whether cells grow and divide, differentiate into other cell types, undergo apoptosis, and disintegrate. So the cooperation among mitochondria is essential to cellular function. And so I would venture to guess, I believe that having all of those mitochondria come from a single source and be essentially daughter organelles would be very conducive to that cooperativity. Whereas if you had mitochondria from different sources, they might actually undergo competition. And so that could be fairly detrimental, deleterious to the survivability of the cell and the organism.
That's interesting. Do you guys see that with other types of cells?
Well, so in all animals, the mitochondria comes from the mother.
Yeah, no, I mean, I'm sorry. I meant, do you see that competition happening with other types of cells?
Do you mean other types of cells that might have different sources?
Right.
Well, that doesn't occur.
It doesn't occur.
It doesn't occur. Yeah. I mean, there's very rare circumstances where, as I mentioned, some of the paternal mitochondrial DNA might make it in. But even in those circumstances, because we're actually so related, that the mitochondria, even in that circumstance, aren't too different. So so it's you've got a small amount of the paternal DNA, and I don't think it's enough to really, and they're not different enough to really tip the balance significantly. But if it had been the case that over successive generations for eons, you were getting equal amounts of paternal and maternal DNA, you might have this constant competition occurring between the different sources, the different mitochondria in the cell. You have two different types of mitochondria in the cell. It opens the possibility for competition between them, because they do behave semi-autonomously. And you can actually see instances of competition occurring between maternal and paternal chromosomes, where there are things that, like, maternal DNA will direct silencing via epigenetic modifications to paternal DNA to promote its own expression and proliferation, let's say, in the cell.
Well, that's really interesting.
Yeah. So there is actually examples of this kind of competition occurring at a subcellular level between maternal and paternal elements. So I'm sure that it was really early in the endosymbiogenesis of mitochondria into or ancestral lineage, into the ancestral cell line, that it was probably very early in that process that it was like, okay, we've got to stick with one mitochondrial source because if there's more than one mitochondrial source, it leads to deficits in coordinating activity that is vital to the cell.
What do you see for, how does that express phenotypically when the male mitochondria has been passed over?
I think that in most circumstances, it is fairly inconsequential. It's a fairly rare event, and I think that the paternal mitochondrial DNA has a much lower count than the maternal DNA, even when that does occur. So it's kind of drowned out by the number difference. So it doesn't have direct phenotypic expressions. I'm not aware of any kind of like problems that causes. Oftentimes, like if there is a dysfunction of the mitochondria, you get things like macular degeneration, blindness, and I don't believe that has been correlated or linked with instances where the paternal mitochondrial DNA is added. One of the things, though, that it can do is that when you're doing genetics of that person, it can confuse the results because for one thing, it's normally just assumed that if you're looking at the mitochondria, that is the maternal lineage, the mother's line. So if you also have some of the paternal mitochondrial DNA and you are not aware of that, if you don't recognize it, it can confuse ancestry, if you're trying to give a person their ancestry.
Mm-hmm. Interesting. Thank you. My other question was around perception and whether it is understood that these equations that describe physics or physics equations have perception built into them. Do you know what I mean by that? So, for example, like Planck's equation, I believe this is Planck's equation, equals HF, right? So the frequency, the higher the frequency, the higher the energy, right? And if we look at frequency, so the more we raise our vibration or our understanding of reality and who we are, our frequency increases. So that means our energy increases. And so I was just wondering if this was understood in this way.
Yeah, I don't know if physicists would apply that kind of purview to it, that kind of perspective to it. It's like
because I really believe that is why Jesus and the master, certain people are able to perform the miracles that they were, because if you think, if we're a holographic, if this is a holographic universe and the universe is responding to us, when we understand who we are as the field, we lower our resistance, right? We lower, so we actually, we become less dense, right? We become less dense and our frequency rises, right? So the whole, our bodies and the mitochondria, because I bet you if you do studies, I really believe that if you do studies with people that have this understanding, that really understand the nature of reality, to the point that it's not just a concept in their mind, but they actually feel that the universe is them, that the field is them. Because when you do that, you literally drop the density, the dense feeling in your body, right? You elevate in vibration. And so your energy goes up. I bet the mitochondria will be pumping out a lot more light, a lot more energy. And if you think about all the words that we use to describe health, like vitality, vibrancy, enlightenment, right? So then that is all a consequence of that. So when we raise our understanding of the nature of reality, or the reality in our relationship to it, that we actually are the field, and then we know how to use our own mind, and really, which is just intention, to tap into the field, then that lowers our density, that allows more light to be expressed through the mitochondria, because we're pumping more protons through the ATP synthases. Does that make sense?
Yeah. So you know, I think that there is that process can actually be expressed via the mathematics, as you pointed out. So you know, as you're increasing in frequency, this is something that is literally occurring.
Yeah.
Yeah, and you know, frequency has so many correlates associated with it. I mean, also like, for instance, information exchange. You know, so increasing the frequency, the literal vibrational oscillatory frequency of the molecules in your body, in your mitochondria, is increasing the rate of information exchange. More information is being processed, there's greater awareness, higher levels of consciousness, and you know, that, you know, E equals HF, you know, it's actually, you know, increasing the energy that's in the system.
Yeah.
And that, you know, I have no doubt that that would correlate or correspond with increased photogenesis, so, you know, increased photon emission, particularly by the mitochondria. So you know, I think that in answer to your question, you know, the role of perception is there in the equations, even if it's not, let's say, recognized by conventional
Right. And
scientists.
I think that that's an important piece. I think it needs to be recognized.
What would you say about that, Ines?
Thank you. Yeah, yes. Yes, I would like to say that I would propose a little change of view with respect to what's dense and what's subtle, because the highest density is inwards. What we understand it as more subtle, but it's infinitely more dense, infinitely more energetical, but it is much more coherent. So reality, it's like when we are expressed as we are now, it's many processes have already taken place, and we are like the resultant of that, which is basically the screening across all scales. So this is the less dense part of existence. I mean, we're going to less denser regimes. Then we go even less dense, which is universal scale, which is the energy at the universal scale is precisely the problem called the catastrophe, the vacuum catastrophe problem, because when you measure the energy density at cosmological scale, it's just of a density of, let's say, 1 proton per centimeter square. When Whereas when you go deep into the field, the deeper you go into the field, the higher the energy density, up to the point that you have 10 to the 93 grams in that in centimeters square, square, right?
Cubed.
Yeah.
Cubed.
Yeah.
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 Yes. So what changes in reality is more the coherency. The coherency is more coherent while you go deeper, which is why you can have more compactification of energy, let's say, of information. And as that information screens across scales, as that energy transfer screens across scales, then you have decoherence, and then you have these different, let's say, fractalized events that we call, or energy levels that we call cell, human being, planet, stars, and so on, not like going from to the outside. That would be something that I would add to that. Maybe it's just more coherent, but much more energetical, which is why you can go deep. So when you want to see how these energy fluctuations are, and this connects to a question I think I saw just a while ago. When you want to, someone that asked if there's a way that through consciousness you can go into, if the model, the holographic theory has any way of explaining how we could be aware and perceive, be conscious of that popping in and out of existence that all of our cells and all of our protons are doing at the speed of light, right? Because we're popping in and out of existence, and so we would like to feel that. So half of the time we are in the vacuum, we are literally in the vacuum, being in the vacuum. So how could that fit into what you're saying? Is that yes, of course, if you manage to go, that this is like the image I have is like a diver. Okay, so when you're in the sea, you have you noticed that you can go infinitely far in the space, and to our scales, we can go very far to the outside. But have you noticed that to go inside inside the water or sea, in the sea levels in our Earth is basically impossible? You cannot go dive more than, not a human being could be there. But and even with our machinery, 12,000 kilometers is at most that we have achieved to go deeper into the. So that's how dense. That's the same image. So how can you do to go into that density, you know, and tap into something that is so dense that you cannot, that you would probably not survive if that was like using the parallelism with the diver. And so I think that requires, going into this, so psychologically you have, I don't know, through meditation, through many things that you have to experience in a personal way, probably, then you would be able, and I think it's possible to tap into that density and go into that state in which you could feel that that coherency and that density. And also, but if you arrive to that stage, then you probably would have, like what the Buddhists call the possibility of dissolving your body in a rainbow body, you know, like a light body, right? and so that would be that would be something I think it's possible. And if you understand the flowing of the energy and the understanding and this gradient between scales, you probably have a deeper tools to go into that meditations, contemplative states, and reach that kind of understanding and of connection with everything, no? So that's what I would add. And maybe something regarding the vibrations. When we use the equation E equal H V, well, frequency, or H bar frequency, or this equation, when you see the vibration modes concerned in everything that we are experiencing, it's not just one vibration. It's like you have the normal modes of vibration, which are the vibrations that are allowed, because that's why we are quantized. What that means is that light can travel at any frequency, so it's not confined to a certain rules of vibration, let's say, because it's flowing at all frequency, let's say. But matter, that's the difference between light and matter. Matter is a confined vibration. It's only allowed to vibrate in certain frequencies. Okay. And the proportionality constant that goes from one to the other is precisely the speed of light, in such a way that it is what keeps things from staying confined and not propagating. You could see mass as a propagating, you could see mass as the potential to propagate vibration, but it is still confined. And you can see light as a propagating vibration with a potentiality of being confined as well. So there's like this kind of game between light and matter, no?
Mhm.
But basically the main difference is that light is propagating vibration, which can vibrate at all frequencies. So you have all frequencies available, while matter is just a confined vibration. So it's only allowed to vibrate in certain modes, and other modes are not possible for it to vibrate. And that's basically what quantization means. And so then when you have that, and in some aspects, that's what quantization means. And so then so it's a trick, I guess, how to release this energy in a conscious way, so that you can understand your own modes of vibration, and enhance them if you wish. No, find these modes of vibration and find a way to enhance them, and know them, understand them, and know them, and then play with them. You know, like it's not just one vibration. That's what I'm trying to say, that we have many modes of vibration. And so the combination of all those modes of vibration, if you had them all like the totality of all then you would be light.
Right.
You would, because it's vibrating at all frequencies, you know.
Yeah.
But we have to do this transition from mass to matter to light, and then the other way around, from light to matter. And so that's interesting.
Mhm. Yeah, thank you very much for that clarification. I understand what you're talking about, the density of the vacuum. What I was really referring to was how the human body feels, the density of the human body. So, right. So in certain states of consciousness, you feel like, in my human state of consciousness, where I feel separate from everything, I feel more dense. But I've reached certain states of consciousness. I've actually experienced myself as a light being, where every single part of my being felt like a light. It felt so beautiful and amazing. And I'm on the journey of being able to get to that state again. And this is like learning about all of that. And what I notice is when you elevate yourself and you expand and you feel the space around you, and you understand that you are one with the space around you, you are the field, that's when you can start reaching that state.
You know, you're bringing me this image, which is beautiful. Maybe what we would say, because many people use this image of being more subtle, like less dense. But maybe what that means is, since you're already unifying more to the field, then it's like the fish recognizing the water.
Yeah.
And so you don't feel that pressure anymore. So you're being in a much denser state. But since you're now permeating with the surroundings, then you feel less confined, less dense.
Yeah, less dense. And also I'm able to tap into the field. So I feel like I feel like the Big Bang is the center of the chest. I feel like it's the heart. It's what's called the spiritual heart. It's not the heart chakra. It's actually deeper. But for me, it's an infinite source. I can just tap into it, and it's enormous, and it just keeps getting bigger and bigger. It feels like there's no end to it. Yeah. Right. But thank you very much. I really appreciate all of that. Thank you so much.
Thank you so much. Thank you. I saw there's a question here. Maybe we can address the next question from Jill. Yeah, we have a little time. So Jeff Kohlberg, and maybe we'll have time for these two questions. So Jeff Kohlberg is asking about the Alpha Day. I think Nassim mentioned it the other day. He's mentioned it in a couple of interviews. What can you share about the Alpha Day, September 16th, just the past of September, when Nassim did the last piece of the puzzle into the place for unification of forces with the alpha time structure constant? fundamental physics constant, which quantifies the strength of the electromagnetic interaction between elementary particles. Yeah. Okay. Hi, Jeff.
Hi.
Hey.
Well, how you doing? Thank you. I was excited. I was listening to Greg Braden and Nassim over at Humanities
Oh,
Teams. And
yeah.
that's when Nassim was so excited. When he mentioned that date, he said that was the time. And he called it the Alpha Day. So he said, this is the day that it all
came together. Right? That it all came together.
Oh,
Jeff, you're muted.
no, he got
I'm
kicked
actually
off.
in there. Hey, you actually got you fixed it. So I mean, I'm like, and he was saying this is the day that's going to go down in history, and
Yeah.
it was like, and I go, wow, what a day! I said, this is the day we'll all be celebrating. This is going to be a historic event, and it was, of course, he and Greg were having a ball over there, when they get together.
Yeah.
And
Yeah.
I did, to me, it was like a signal that that was the end of the now we just have to publish it. But he put the last, I used to, when I was teaching at New Thought churches, I used to say science was like a jigsaw puzzle, but they were cutting out the pieces to fit in because they didn't have the right piece. So they were making up the piece and cutting it to fit so that their puzzle would look like it was finished or like it was the standard model. So that was my analogy for how the standard model forcing pieces in. And when Nassim said it just slid in, he had finally had the final piece to understand the alpha constant, and it went in and it sounded like it was done. And I said, wow. And he had a date, and it goes, I said, that's going to be the date that we'll all be celebrating historically. So I didn't, but I wanted just to hear anything you guys said about that as well.
Yeah. Okay. So we can share a little. It's that the alpha constant popped up in a certain aspect of the alpha constant popped up a long time ago, which is what allowed to do many of the calculations. But it popped out in a certain scale, like at the scale that it was expected to appear, it popped it out from a mechanical point of view, so from a certain mechanism, and that's it. But the problem was that, what it was not completed is how to have this alpha scale, like how would it connect to other scales, no? So that was a part that at some point that part was still missing, and so that's the part. So the origin of it was pretty clear. So, but how would it connect to some other scales was something tricky, still something tricky, and that's what I from what I know it had to do with that at some point. And but
how Nassim gets, he was beside himself. He's just, he goes, ah! He was just so excited about it. It was just like, his excitement penetrated through me. And I thought, wow, this is going to be the date, he's set the date for our celebration of the paper, really.
It's a good thing. It's a good, I think so too. That would be important for sure.
And the alpha constant is extremely important. I think it was Richard Feynman who said that every good physicist writes this number up on the wall and worries about it. Just that it is a very interesting, even perplexing constant in that it shows up everywhere. And it's not entirely clear, especially from conventional modern physics, why it shows up everywhere. Because it's like, it's primarily related to the strength of the electromagnetic interaction, between the electron and proton, and it's a unique constant in that it's dimensionless. It doesn't have arbitrary units. So most of our constants are like, kilograms per meter squared. So in that case scenario,
Is that like pi? Is that like pi?
well, like pi, a dimensionless number. Yeah. But in most of the physical constants that are utilized in physics equations, they have those arbitrary units of measurements because we define what a kilogram is. We define what a meter is. So if you have like a alien civilization, their value for that constant would be different because it's unlikely they'd be using kilograms and meters. But that's not the case with alpha. No matter where you are in the universe, what civilization you're in, you'll have the same number for that constant because it's not based on any kind of arbitrary units. So the fact that they have solved this puzzle is tremendous. This is going to be a big deal.
It
Let
also,
the party begin.
You just mentioned about the pi constant the pi. I had exactly the same feeling about alpha. That is had to do with something having to do with rotation. I mean that pi, because pi comes from dividing, So it's very interesting that it had the same meaning for me, like alpha and I don't know, some kind of angle, some kind of rotation, something's got to do with that division, and it goes on that direction. So you were not far from that. It's interesting.
I'm not quite sure how machines were struggling with trying to figure that out. Or, I don't know the whole story except that, how he was struggling to get the last part of being able to fit that in.
Yeah.
Other than he shared the day that it happened. So we'll know more, eventually a little, what happened to him on that, how he fit that in. It's going to be exciting. But I think that'll be the day we celebrate. As he said, it's going to go down in history. And I think that's the day we'll be celebrating for, the world will be celebrating that's September 16, 2022. So we ought to plan a party for next year.
That's a great
1 year celebration of that day, because
That's a good idea. Yeah, I think so too. Thanks, Jeff.
Thank you.
And so we have maybe a time for a last question. Let's say maybe the next one would be Simon Kosnick. Oh, that's the one we already kind of addressed. Yeah, those Nassim.
What about entanglement and consciousness?
Oh, yeah. Okay, let's go there. That was made by
Michelle?
Michael.
Michael. Oh, sorry. I misread that. Michael.
Michael Diels. So maybe it's Michelle. Maybe it's a French.
They might have jumped off the call. It doesn't look like
that he's connected.
Yeah. But we can still address the question.
Okay.
Unless is there another one you might have saw?
Oh, wait, let me see from someone here. That one or Simon Cosmic, because the other ones have been addressed. Answer it anyway. This is recorded, says John. Okay. Yeah. Okay, so let's go into that. Yes, entanglement. They want to go there. Yes. Okay, perfect. Go ahead.
So there's the purview of entanglement in consciousness that has been popularized by the Copenhagen interpretation of quantum mechanics. And I think that that's a good place to start in addressing this. That's the Bohr-Heisenberg model of quantum mechanics that was opposed by Einstein and some of his colleagues. So, at a conference in Copenhagen, they got together, these founders of quantum mechanics, Einstein, Bohr, Heisenberg, and others, and debated the physical mechanism of what they were observing in things like the double slit experiment with light, where the single photons appeared to be interfering with themselves as they passed through these two slits to generate interference patterns, almost as if they were going through both slits at the same time. So in the Copenhagen interpretation, as it's called, they came from Bohr and Heisenberg. Their solution to this was perhaps a bit on the mystical side of things, and that they posited that, well, the particle isn't really there. This produced a situation where you have two different camps. One of them is the camp for realism, that the particle is real, and the camp that the particle isn't real. In the Bohr-Heisenberg interpretation of the experiment, what you do have is a superposition, where since it's not a real thing, it can go through both slits, interfere with itself, and produce the interference pattern. That is not the only, I should say that an important aspect of that, as it relates to consciousness, is that one of the things they posited is that what causes that superposition, this wave function, to collapse into a definite thing that we see as a particle, into a real thing, let's say, is by the act of observation or measurement. It's not entirely clear if, they thought that that necessarily required a person with consciousness to do that measurement, because there's other ways that the superposition can collapse via decoherence. So just almost any kind of interaction with an outside system can count as an observation, as a measurement that collapses the wave function. But it definitely was a part of the interpretation that what made this particle real, instead of just a wave function, the superposition is the act of measurement by a conscious observer. Now, that's not the only interpretation, though, that exists. In fact, it's one of the only interpretations in quantum mechanics that has this wave function that collapses, a superposition that is reduced. Almost every other interpretation of quantum mechanics does not have the wave function disappear, does not have that superposition go away. The wave function and the superposition remain indefinitely. All that occurs is that it goes along and becomes more and more entangled with the system around it as it interacts with the system. So you just get increasing levels of entanglement. An example of this is the Bohm pilot wave interpretation, the Broglie-Bohm pilot wave interpretation of quantum mechanics, where the particle is real. It has definite properties, but it always has a wave function associated with it, as well as what's called a pilot wave, so that it can actually interact with its own wave form in space. So uh, the Copenhagen interpretation, as it's called, that kind of refutes realism, is probably the weakest of the possible explanations for what is observed in quantum mechanics. It really comes up short. And actually, if you start to analyze it in a greater context, you see some very intractable problems with it. For instance, how do you define the observer? Because so, for instance, the approach that we take is that almost anything can function as the observer, particularly because consciousness is ubiquitous. It's a fundamental attribute of the universe. It's involved in the evolution and development of the universe and the creation of matter and substance and form. So you can't arbitrarily define one system as aware and conscious and another as not aware, not having this consciousness. So, that's necessitated within the Copenhagen interpretation. It's the view that only humans have this attribute of consciousness and awareness. But in a serious analysis of the situation, that's an arbitrary designation. And you can assign the role of observer to almost anything. And when you do that, you kind of circle back to the more predominant understanding that the wave function, the superposition, the entanglement never ceases. It's always there. And we've taken that and expounded on it to show that, well, that entanglement network is part of consciousness. So when you're talking about what is consciousness in the universe, it's very much that entanglement network, all frames of reference in the universe being able to instantaneously coordinate and communicate information, quasi-instantaneously through the Planck micro wormhole network. But collating all of that information from all these different frames of reference is part of the process that is consciousness, that is awareness in the universe.
Yeah, exactly. It's you reminded me when they were having this discussion, Bohr, Einstein, like they were friends, but they would hardly, they were really in disagreement on that part. For Einstein, it was like inconceivable. So he was saying that quantum mechanics therefore was incomplete. Like he would say, no, that is not possible. Therefore, our reality has to be deterministic. I mean, it's very probable that we have missing variables, like hidden variables at play that we're not seeing, we're not looking at. And so that's what's happening probably. And so Bohr would say, no, the theory, in reality it is complete. So what was the discussion that was underlying was the completeness of the theory of quantum mechanics, of course. And so that so at the end, and you could read a little bit more in this article of entanglement, that of the Nobel Prize awarded to entanglement. I give a little explanation on that. But the thing that hidden variable, it was proved that in fact local hidden variables were not at play. That was proved. So that kind of gave let's say that gave the arguments in favor of Bohr and on all this Copenhagen interpretation seemed to be correct, because it was proven that local hidden variables were not at play. The thing is that non-local hidden variables is still the thing is that there's no what the non-locality. So they're saying, okay, entanglement is non-local. Okay, we have proven that because it has been proven that entanglement exists. Okay, but we have proven that there's no local hidden variables. Okay, so that means that this is a spooky action, just as Einstein said, spooky action at a distance that you cannot explain because there are no hidden variables. But that's not correct, because of course it's still not clear. It's still a matter of debate if the non-locality is something intrinsic to the quantum theory, or if there is non-local hidden variables at play, which is the other side of the coin, in which is exactly what we sustain in our theory, that there are of course non-local hidden variables all the time at play. So quantum mechanics is in fact incomplete. So in this sense, Einstein was correct. I mean, quantum theory is not a complete theory, it is incomplete. And which is the reason why as well, when you have the Schwinger equation, it's missing. Schrodinger equation is a wave function equation, is a wave equation, but it's missing the source of energy. So it explains like a wave function, but it is not as a normal wave function would have everything having the same order, second degree or second order in all the terms, because in the Schrodinger equation there's something missing, which is the source. So that makes it that you have on one side of the equation second order degrees, like derivatives of second order, and on the other side of the equation our first derivative, which is time, which obliges the equation to have the imaginary factor in that side of the equation with the time evolution. It's got an imaginary equation, and that makes a huge mess, a huge confusion for quantum mechanics. Why? Because then you have to force the equation to not be a real equation. It's got to have. So when you read the Schrodinger equation, the solution you give, it's an imaginary. It's got imaginary terms in the solution, so you cannot account for a real system. Which is why they say, okay, so these particles are in a superposition of probable states that you have to do, and you have to collapse them to the most probable. It will collapse to some of these states with the highest probability, and so it all remains in a kind of hocus pocus probability realm where nothing really exists. Because if this, and so you wonder, well, how did this phase transition happen that we suddenly are now here, real, deterministic, everything is existing? So how did phase transition happen? It has no sense. Of course it has no sense. But the worst consequence of that is that because of this inconsistency between the order on the terms of the equation, then you have that the spin of the particle is considered not real. So the spin of the particle is considered not real. So, but of course, when you have an imaginary number in the term, it is talking about rotations. It is clearly talking about Euler. So there's evidently some rotation implied. So, but they're stuck at that point because it cannot be a real rotation. So the spin cannot be real. And this is where a big amount of physicists said, okay, something's wrong with this Schrodinger equation and this interpretation, and it is in reality incomplete. And they have tried to develop a new model, a new theory where these rotations are real. This is called Sitter-Bewigen, the whole movement of Sitter-Bewigen defendees, which we are part of, that say we just have to understand that this term is a real, is expressing a real phenomenon, a real movement of the electron, which is this rotation, which is the Sitter-Bewigen, which is happening at the speed of light. And so then you would contradict. This is huge confusion happening because of what? Because we are lacking the source. So since we don't have the source of mass, the source of energy, then everything is happening. Everything is incomplete, and we're forcing interpretations. That's what's happening. So we have been forced to force interpretations into things that are not logical, that are really contradictory. And that's what it's not allowing for unification of scales either, because you have to go connect the cosmological scale to a quantum scale, which is not properly described through this quantum mechanics. It is incomplete. So, and that's what Nassim's bringing forward, Nassim and Olivia bringing forward. If you include the source, then Schrodinger equation, you have nonlinear, it's completed, and so then everything else falls into place and everything's sorted out. So that's something, and this connects to consciousness. Why? Yes, because entanglement then, as William was saying, it's everything is if we have non-local hidden variables at play, that in that everything is connected, then of course we have as someone was saying in the comments, then we would have to include entanglement as a source as a source for reality, and it has been hinted in many works in physics. They say that entanglement is the source of space and time, and that is probably somehow the case. Okay, so and connecting with consciousness, this is very important that entanglement has been finally recognized as it's being moved forward, because this is something that was published in 1980 by this physicist, this neurophysiologist I already talked about, Jacobo Greenberg. He has a work in which he demonstrated, he was a pioneer in Occident in consciousness studies, because he was already working on that topic of proving entanglement through interaction, through people who were, let's say, connected somehow because they were a couple, mom and dad, or something like that. And so he would place them in different rooms, and in one room there would be a Faraday cage, and in that person, so he would ask for them to think of each other, so they were connected like emotionally, and then he would do this experience on one person, which is he would flash a light on this person, and on both persons they would have EEGs taken at the same time. Okay, so they're having these EEGs measured all the time. This one person is in the Faraday cage, he's receiving this stimuli to his forehead, let's say, and both EEGs are being recorded, and you won't believe what happened. And their proofs are there. I mean, this was published in Physics Essay in 1994, the year that he disappeared, because this researcher, he suddenly disappeared. He had created a consciousness lab in Mexico City, in the university, the most reputable university in Mexico, called Universidad Autónoma de Mexico, the most important university in Mexico. He had created a consciousness studies laboratory there, and he was funded by government. He was funded by taxes. I don't know. So yeah, public fundings, and he wrote about 50 books. He was studying shaman brains and all that. And one of his latest studies was this one, to prove the transfer potential, what we call the transfer potential. And you will see that both EEGs were showing this at the moment of the stimulation, they would be having the same signal, not at the same intensity, not the same intensity, of course, but the same signal would reproduce. And then each one would go on their way. But at the moment of stimulation, the signal would reproduce. And they did it hundreds of times with many people. So it was proven. And so he published a paper saying Einstein, Podolsky, Rosen as an explanation for that phenomena, which is entanglement. So this is extremely important, because that was the work that had already proven that consciousness, of course, is entangled. I mean, we are entangled, everything is unified, and we are all connected. And that was a proof, a physical, scientific, published in peer-reviewed paper, connecting both points. So I will share that we had been keeping some studies of what he had done in some experiments that at some point we'll maybe talk in another moment. But I will share that here in the chat, so that you can see this paper. I hope I have it at hand. I'll share it here in the chat. The paper about, oh wait, yeah. I'll just share it in a while. Just give me a second. Because it's really important. This is like so important. Wait. Okay. So, okay, so. Okay, so I'm gonna put the link, and if you can download it, it's a ResearchGate link, and it gives directly the paper of this transferred potential. It's published, you can see it here in the chat. So you just have to go into that site and download the paper, and it's available for everyone. So it's really important for you to take to have that in your, like, you know, in your bibliothèque, I don't know, library, to have that, because it's a proof of entanglement and consciousness. Well, I think, yeah, that's yeah. Okay. Well, and if you want to see the documentary about this person I'm mentioning, is The Secret. I'm going to write it here also. The Secret of Dr. Greenberg. So we are having the idea that through the generalized holographic model and the unified field theory, we would be able to explain these experiments, because of course they say Einstein, they say that they mention entanglement as a possible explanation, but as I said before, quantum mechanics does not explain the origin of entanglement. It predicts it, but it doesn't explain why it comes to be. So it is incomplete. So that's another way of saying it is incomplete. It's not explained. So through this, through Nassim's unified theory, we would be able to explain this kind of phenomena. So yeah, that's The Secret of Dr. Greenberg. Okay, could you save the chat history at the end of the session? Okay. Do you know how to do that?
Yeah, I remember to do it this time. So I've got the chat history saved. So that'll be made available along with the recording of this video. So it'll be there on the contributing members portal of the RSF site. You'll be able to access the recording of this video, see the chat history as well.
Perfect. Well, this is great. This is great. Well, I think we could, like.
Yeah, I think we've come to the end of our allotted time. It's gone so quick. There's definitely a couple other questions that would have been great to get into, but we'll have to save those for next time, as usual. So always more topics, more questions to discuss than we have time available. But that's one of the reasons I always look forward to our next Resonance Academy faculty Q&A, so that we can get back into these conversations.
Yeah.
Thank you all for joining us, and we'll look forward to seeing you in our next live virtual events, the breakout group session, the next Resonance Academy faculty Q&A, your participation and the insights that everyone brings. It just makes these such expansive experiences. So thank you all.
Thank you, everyone. See you next session. Thanks for being here. Thanks, William.
Thank you, Ines.
Goodbye, everyone.